Hello everyone, and welcome to 2025. This is the year that the decentralized internet ecosystem and AI gets real. So last year we already saw the internet computer begin to host AI models in the mode of smart contracts, including large language models. And during 2025, we're going to see further increases in performance and in the number of parameters that these models can use. But today, we're going to be talking about the self-writing internet. This is a completely new paradigm where anyone, anywhere in the world, can interact with network intelligence using natural language to build out their own sovereign corner of the internet ecosystem. This new self-writing internet paradigm is going to be tremendously impactful and ultimately change the way tech works. And I believe in 10 years, as a result of the self-writing internet, many things will be completely unrecognizable. Okay, so let's get started. The title of the talk today is Where AI Builds. So let's begin by considering what we're going to see tomorrow. And I can promise you this tomorrow is not far away. So we're going to be chatting with AI to create running web applications and internet services. This is an inclusive, broad paradigm that empowers everyone. An individual might want to create a personal branding website where they can make blog posts, share photographs, share files maybe, or maybe they want to create a game to share with friends or a web application for planning and organizing their wedding. An entrepreneur or small business owner might want to create an e-commerce website or a sharing economy service with Web3 Rails, say. A corporation or government department might want to create a corporate portal or CRM or ERP functionality, which they will otherwise have to obtain by signing up for some incredibly expensive SaaS service where they become locked in, their data gets stuck, and they still have to spend a lot of money on consultants customizing the functionality. Of course, this new self-writing internet paradigm isn't just about the initial act of creation. You're going to start out by chatting to the AI. It's going to return a URL to you, which you're going to click on, and it's going to open your browser, showing the web application or internet service that you created. But of course, you're going to want to improve that continuously by chat, both initially and over time. And the paradigm will allow you to do that. You'll simply talk to the AI and refresh your browser to see the changes. Even when you're updating an internet service that might have hundreds of users and there's a ton of data inside that you can't risk losing. So this is a completely new paradigm where we simply describe to create and build out the internet ecosystem in ways that we want. But this new paradigm has been enabled by the confluence of two other paradigms. On the one hand, we have super advanced large language models capable of writing highly sophisticated code. On the other hand, we have the internet computer, a compute network that's been optimized for AI and has properties that allows it to build solo in a safe way. And the result of that is that we can produce applications like Caffeine, which allow us to interact with AI to simply create web applications and internet services through describing what we want. So now we've taken a peek at the future. Let's rewind a little bit and review some of the challenges we'd face if we tried to implement the self-writing internet paradigm using traditional IT. So we'll start off by considering the complexity of current IT in the traditional tech stack. So the easiest way to convince yourself that it has unbounded nuance and detail is just to have a look at the sheer volume of technical documentation that exists. It stretches into the hundreds of millions of pages. And this complexity is the reason that IT personnel today spend 95% of their time chasing complexity, focusing on how they build rather than what they build. And it turns out this is not an ideal stack for AI that wants to write code and upgrade running systems in one shot. The next big problem I want to talk about is cyber security. Current IT depends on protection by fallible cybersecurity tech. That means that we use things like firewalls to prevent hackers getting inside our infrastructure and infecting it. But one configuration error, one software patch with malware hiding inside, and ransomware and data exfiltration attacks can succeed. That means we can lose both our systems and our data. Unfortunately, this is an unfixable situation. Current IT involves a paradigm where a stack of software runs directly on silicon. And as it turns out, there is no way to get firm security guarantees with this architecture. So to summarize, there are quite a few problems with having AI building solo on current IT. Firstly, a hack is one hallucination or mistake away. And we have to assume that even the most advanced large language models will make mistakes and suffer hallucinations. So that's really a showstopper. It can't possibly be the situation that we talk to an AI and it updates our web application or internet service in a way that results in it getting hacked. But there are also other major problems which are more subtle. For example, current IT isn't designed to allow web applications and internet services to be upgraded at chat speed. And in addition to that, errors that occur in migration logic can result in data being lost. And that again is a showstopper. Imagine creating a user forum which is used by hundreds of thousands of people and then talking to the AI to add some new features and then all of these old forum posts disappear. That can't happen. Another issue is that current IT installs and admin can be incredibly slow and involve problem ladders, which we've all experienced ourselves in different ways. It might be necessary to upgrade the database on current IT, and then you find that it needs a new library, but the new library only comes with the next version of the operating system, and so on. That's not a chat speed operation. And similarly, current IT is incredibly complex. So when you upgrade something like a web application or internet service, there are lots of different components that have to be upgraded in a synchronized way. And that's time consuming as well as complex. And it doesn't happen at chat speed. So now we understand the problems involved with having AI build solo on current IT. Let's move on to how Internet Computer Protocol, ICP, makes it possible. So this is the Internet Computer Network's dashboard. It's a big network that is hosted on sovereign hardware run by more than 130 node providing organizations around the world. Internet Computer Protocol in the public setting creates a permissionless world computer where you can just upload to create and update web applications and internet services. And currently there are already thousands running, but we believe the self-writing internet paradigm will quickly drive that up into the millions. So ICP addresses tech fragility. This is incredibly important because complex traditional IT is impossible to make reliable, and even its foundations are highly vulnerable. It's built in a centralized way from numerous platform components, and the resulting complexity is a key source of the lack of reliability. It's also vulnerable to cyber attacks and in the future, things like state sabotage. And the problems are in plain sight. This summer, a patch was applied to the CrowdStrike platform software system, and it caused 8.5 million systems to crash and prevented their restart. Back in the day during COVID, an Amazon Web Services data center outage caused the New York subway to stop working. This is a lot for one-shot AI to deal with. The good news is ICP goes much further than fixing fragility. It creates a revolutionary compute stack that is immune to normal cyber attacks, a new kind of unstoppable compute stack that is ideal for one-shot AI. Compute is replicated across distributed hardware using a mathematically secure network protocol within which is hosted a virtual execution environment that holds a cloud computing environment. This is a revolutionary approach that is a departure from the paradigm of current IT, where you have a stack of software running directly on the silicon. This mathematical network protocol has a property known as Byzantine fault tolerance. This means that even if an attacker gains physical control over some of the hardware involved, although that might enable them to steal data, it will not enable them, under any circumstances, to break the network or corrupt data of any of the web applications or internet services that it hosts. This is the beginning of a compute revolution, and it's also the perfect platform for AI to build on. In this revolutionary new internet compute stack, the complexities relating to failover and cybersecurity are gone. You just upload serverless code and go. And this serverless code is highly abstracted logic, but it's all that you need to create and update apps. So AI can code, upload the code to the internet computer, and then a couple of minutes later, max, the new experience can materialize. And these apps and internet services are tamper-proof, so there's no need for the AI to manage cybersecurity measures. And they're unstoppable, so there's no need for the AI to measure failover and backup. ICP goes further still. It introduces a new compute paradigm called orthogonal persistence that really reimagines compute itself. With this paradigm, data and logic are very much the same. When only abstract logic remains, then we define what rather than chasing how, and this is ideal for AI. On the internet computer and on any other ICP platform, there are no files, there are no databases, just unstoppable logic. And this is why we say that data persists orthogonally. Now, take a look at this simple code here that defines a blog. Here's a data type defining a post. It has a title and a body. Below that is a declaration of an array of posts. This declaration is all that's necessary to have the blog maintain its list of posts. Now, compare that to traditional IT, where in order to persist the blog posts, you'd have to marshal them in and out of a database server. This is quite literally orders of magnitude more simple. And this again is very good for one-shot AI. Now we get to some of the real secret sauce that allows AI to build solo on internet computer protocol stacks. AI needs to update apps at chat speed, and ICP makes this possible by allowing code to efficiently morph memory during upgrades. But there's more. Domain-specific languages like Motoko, which are optimized for AI, leverage ICP features to ensure that during these data migrations, during upgrades, no data can be lost. It's called loss-safe data migration. So rewinding to our example, here's our initial definition of a blog post. It's just a title and a body. But we want to update this so that a blog post also maintains a count of the number of likes. So the AI would actually upgrade this blog in two passes. In the first pass, it would update the original definition of a blog post to add the likes field. In the second pass, it would write a migration file describing the logic that would update the old format blog posts into the new format blog posts. Now, what's super cool is that this will not compile or install on the network if it would result in data loss. And in fact, the updated code would be checked against the currently deployed code to make sure it's just not possible for something to get lost. And hopefully from these last few slides, you're getting a sense of what I was talking about at the start of this presentation about the confluence of advanced large language models that can write code with compute platforms that are designed to enable AI to build solo. Okay, so where does this take us? In the future, the self-writing internet paradigm will enable us to create web applications and internet services at tiny cost and with massive speed. Here I've suggested 1% of the cost and 100x speed up. This sounds extreme, but I can tell you, in my own experiences with this technology so far, I think it's realistic. And these applications will be scalable, efficient, interoperable. They'll support Web3. You'll be able to create new AI from AI. And of course, it'll all be decentralized and sovereign. This is the new paradigm. And this is what I believe is going to change tech forever. And now we're going to talk about the elephant in the room, which a lot of people have expressed concern about. What does the self-writing internet paradigm mean for the millions of software engineers and designers around the world? Well, I believe that it's going to result in more growth and more employment. First of all, the self-writing internet paradigm will empower 8 billion non-technical people to create web applications and internet services. Some of those, of course, will enter roles in tech, become prompt engineers. Some of them will even become tech entrepreneurs, and others will join new online communities. As the result of their activities, we are going to see millions and millions of new web applications and internet services being created. And inevitably, some of their owners will require professional human assistance. And that will mean, in my view, more work for software engineers, user experience designers, and growth hackers. So the future is bright, and it involves the self-writing internet paradigm and internet computer protocol, the most sophisticated network protocol ever engineered by a mile. Democratize, decentralize with advanced technology. I worked for the Dfinity Foundation, which is designed as a NASA for decentralization, and we bootstrapped ICP technology through more than 1,000 person-years of R&D effort. Our mission is to make compute secure and unstoppable and enable AI. So thank you for listening. If you'd like to get more updates from me, follow me on X and feel free to get in touch with the foundation. Thanks again, and bye for now.